All right, so today we're looking at traversable graphs. So a traversable graph is when you walk a trail, so you go through the network and you include every edge. Now, a traversable is a connected graph. So if you remember, we said a connected graph means that you can get to every vertex without taking your pen off. So you can see there I did not lift the pen. I can get through all the vertex. Now a traversable one is a connected graph, but it's when you can get to all the vertices without using an edge twice. And you don't lift up your pen. So if I look over here, you're going to watch me. I'm going to go through it with the highlighter. So I can go down there along that edge, up here, down to B and down to C. So I've gone to every vertex and I've touched every edge, but I haven't doubled over. If you look over at this other graph network, it's not traversable because I can't do that. So if you could try it a million ways, but I can't. I'm going to double over. So you can see I start doubling over to try and get to every vertex and every edge. So a traversable one is when you can do that. So look, there's a couple of rules that we can use to remember or to work out whether it is traversable. Now, they said all the vertices are of even degree. Now, remember when we said we had a network, so say that was A, B, and C. So if we have edges and we might have that. Remember, the degree is how many edges are coming out of the vertex. So the degree of C there is 3. The degree of D here is 2 because it's got 2 edges, and the degree of A is 3 because we've got 1, 2, 3 edges coming out. Okay, so if you can get a traversable graph if they are all even degree vertices, or there's only 2 odd degree and the rest are even. So if we go down here and have a look at these little graphs, I'm just making the pen a little bit small. All right, so if I look here, the degree, I'm going to do the degree of all these vertex. So the degree of this one is actually 2. It's got 2 lines. The degree of this one is also 2. The degree of this one is 2, and the degree of that is 2. So if it is 2, if they're all even, they think we can get a traversable graph. So let's have a look. I'm going to try with my pen. So I go up there, across, and you see how I got through all the vertices and using every edge without doubling over. So that one worked. So let's go and look at the degrees of this one. So I'm working out the degrees. I'm just writing the numbers now. 2. This one's got a degree of 3. This one's also 3. This one's 2, and this one's 2. Now, because there is only 2 odd ones, we should be able to get a traversable as well. So let me have a go. So I'm gonna start here, go down there. There you go, I've done it. So you can go to a vertex more than once, but you can't use the edge. So there you saw I went to one of the vertices twice, but that's okay. All right, so let's have a look at this last one. We'll do the degrees. How many degrees is this one down here? Oh, sorry, I'm pointing to here. What's the degree of that one? 1, 2, degree of 3. There's 3. Up here is also 3. This one is 3, 2, and 1, 2, 3. So because this one has more than 2 odd degrees, this one is non-traversable because it won't be possible. So you could try and find a path, but it won't be possible.